I am Chandrasekhar Gupta and we are discussing programming concepts. We have seen a lot of programming concepts already and I think it's the right time to take a dive into functions. Loop is actually used to repeat a set of statements for required number of times, but functions are beyond it. It actually can do the same task if it is placed inside the loop, and in addition to that, it helps in reusability of the code. A function which is written in a single program, you can use it in other programs as well. Let's take a deep look at the functions. Let's try to understand functions. So we have two types of functions basically, which is user-defined function and built-in functions. Built-in functions are printf, scanf, and so on. User-defined functions are the functions that can be written by an user. So function is actually kind of black box. Initially, it takes some input and it provides you with required output. Suppose for example, it will take a, b, c, three integers, and it can give the output of a plus b plus c or a multiplied with b multiplied with c. So it's kind of black box where all the operations will be performed. Now consider a situation. You are holding a test and you have taken marks for 100. Now you have to normalize it to 10. So you have to divide the marks by 10. If you just observe here, we can actually define a function which takes the input of marks. So this task can be done by the function and it will give the normalized score as output. Now let's try to define this function. Consider a function fun which has to accept the input as marks, which is an integer, and it has to return normalized score, which is also an integer. What it has to be written as the first part of the function. This is actually called the return type. Int function, it is taking the integer as an input. So it is taking an integer of marks as the input. All the inputs that has to be taken has to be listed here. These are called formal arguments. After defining the formal arguments and the return type, so the format of the output, integer in this case, has to be defined as the return type. This is the return type, name of the function, followed by the input, which are the formal arguments to this function. It has to be divided by 10 to make it normalized, and we have to send this as output. So if we want to send something as output from this function, we write it with the help of a return statement. Now each and every function can actually carry a value with it while it is leaving. That the value which has to be carried will be returned after return statement. So when you write this statement actually carries the value of m while the function is leaving. Consider this example. It is actually taking two variables, marks and score. It is taking input of the marks and it is providing the score for us. So we have defined a function fun and we have called it. This is called function call. Now we try to make a function call from the main function. So the program execution starts from the main function. It goes in sequence. Whenever it encounters a function call, the control shifts to the function. The function will be executed completely. After the function has been executed, the control actually returns to the position from where the control has been shifted. Whenever it has seen this statement, it will actually move to this function. Now the marks will be divided by 10 and the quotient will be returned by this function. You have returned a normalized score here and this will be replaced at the function call. So the function call will be replaced by the return statement. This line will be modified as such. Score is equal to, as it has returned m will be positioned here. The thing that has to be remembered is whenever the function call actually happens, the control is shifted to this function. The function will be completely executed and whatever is returned by this function, that will be replaced with this function call. If the function has not returned anything, or if the function is not having any return statement, then it will not keep any value over here. It will be some kind of garbage value. Now you are trying to print this value which is returned by the function. After trying to understand the control flow, let's try to understand how the function can be traced. The function calls can be traced with the help of stack. Consider the previous example. If you remember, we have defined a main function and inside this main function we are having the two variables, score and marks.
all the function calls has to be followed in stack. Whenever a function was called, an entry will be made inside the stack. Don't worry if you are looking at the stack for the first time. We'll try to understand it in future. Now just focus on the control flow. As we have discussed, whenever a function call has been performed, an entry to the stack will be made, and this is called as activation record. Suppose, for example, at this instance it is trying to make another function call fun. Then another entry or another activation record will be created in the stack. After the function has been completed execution, it will be removed from the stack and it will return the control to the main function. So only the main activation record will be present inside the stack. Let's try to trace this example with the help of a stack. As we have discussed, the main function call will be made initially and it will be processed in sequence. Whenever a function call has been made, an entry will be or activation record will be created inside the stack. It has created two variables, marks and score. The variables will be created. Now, taken the input of marks, suppose for example, consider we are giving some 55. Now, a function call has been made. We know that whenever a function call has been made, an entry or activation record will be pushed onto the stack with the function call and it has taken the arguments of mark. Now, a variable m will be created and the value of m has been modified here. So, it will be taking a value of 5. Now, it has taken the value of 5 along with it and the execution has been completed. We know that when the execution has been completed, it will be popped off and it will be removed from the stack. But the value which is returned will be replaced with the function call. So, in this position, 5 will be replaced. S will be having the value of 5. In this statement, the value will be printed. After execution of main function, even it will be popped off from the stack. So, the functions can be traced with the help of this stack. Even if you are having many functions, you can just make an activation record inside a stack whenever a function call has been made, and the value can be popped off whenever it has completed the execution of a particular function.